Exercise 13, page 132. This is a very important exercise. We are given ABCD, a trapezoid. M is the midpoint of AB. Okay, I did it here. And N is the midpoint of CD. E is the meeting point of AC and DB or BD. Okay, so I joined the two diagonals of this trapezoid and they intersect at point E. Now, use an appropriate system of axes to show that M, E, and N are collinear. Now, to show that M, E, and N are collinear using a system, we need to choose an appropriate system in such a way that we are able to find the coordinates of E, M, and N in that system. Okay, so I want to choose a system where I am able to find the coordinates of M, E, and N. Now notice, if I have the coordinates of A and B, I can find the coordinates of M because M is the midpoint of AB. And also, if I have the coordinates of D and C, I can find the coordinates of N, which is the midpoint of D and DC, segment DC. Now, how do we choose this system? If I had a parallelogram, it would have been easier. I can choose, for example, if this was a parallelogram, I could choose the system to be A, so the origin A, AB, so I is AB, and AD, so J is AD, so A, AB, AD. Now, if you try to choose this system here you have a trapezoid. It's any trapezoid. It's not even an isosceles trapezoid. So these two sides are not necessarily equal, AD and BC. So if I choose this system here, I would get that A is the origin, so it's 0, 0. B is 1, 0. And C is 0, 1 because AD is J. Okay, but how can I find C? How can I find the coordinates of C? In a parallelogram, I would have AC equal AB plus AD. So I can get easily see that it's AC is 1AB plus 1AD. So C would be 1, 1. But here it's different. I cannot do this because this is not a parallelogram. So this system having A here is somehow useless. And I cannot find any relation easily. I cannot find an easy relation to be able to find the coordinates of C. So what do we do? Any other system starting from having as origin B, for example, or C or D, with any other system as such, we will face the same problem. So we can try to take the system having E as an origin, because even in the other systems, it's even hard to find the coordinates of E. Okay, so I choose E as the origin. In this way, I would get E 0, 0, so it's easy. So I can find the coordinates of E easily. I chose E as the origin, and I chose the vector EB to be I and EC to be J. Of course, you can do it in many different ways. You can choose, for example, ECED or EAEB and so on. I chose these two, and now you will know why. If E is the origin, then I know that the coordinates of E are 0, 0, and the coordinates of B 1, 0, because line EB is like the x-axis, and EC is the y-axis, so C is 0, 1. So I got B and C, okay, which is a good step. I have E, B, C. I still have to find D and A, because if I find D and A, everything else will be easy. I will be able to find M and N, which are the midpoints, and we will almost be done. We just do some vector work, and we can prove that the points are collinear by showing that vectors EM, for example, and EN are collinear, okay? So now, if we take the system E, EB, EC, E is the origin, so it's 0, 0. EB is 1, 0, and EC is 0, 1. So B is 1, 0, and C is 0, 1. How can we find the coordinates of A and D? Can we find a relation between, for example, EC and EA and ED and EB? If we can find a relation, then this would become easier. Things would become easier because I already have the coordinates of E, C, and B. Okay. Now notice that since this is a trapezoid and DC is parallel to AB, we have the second form of Thales' theorem, which says, so because we have the following, so if I consider these two triangles, and these two triangles, I have ED over AB is equal to EC over EA by Thales' theorem. okay, by the second form of Thales' theorem that you already know from before, from grade 9, okay? So what does this mean? ED over EB is equal to EC over EA. I want to write things in terms of vectors, okay? Because I need relations that have vectors in this lesson in order to be able to find the coordinates of D and A. Because you know that the coordinates of D are the same as the components of vector ED, and the coordinates of A are the same as the components of vector EA, okay? So let's transform this into vectors, okay? So this means that ED, if I take K, some number K, such that ED equal KEB, so notice, since ED and EB are collinear, I can say ED is equal to KEB. Then EC would be equal to the same K times EA, okay? So if I take ED equal KEB, then EC is equal to the same K times EA by Thales' theorem, okay? So this is nothing but Thales' theorem translated into vectors, okay? In other words, if this is confusing to you, you can think of it as such, okay? So since I said by Thales' theorem I have these ratios, let's call this, for example, T, okay? Some constant T. Then this means that ED is equal to T times EB, okay? Without vectors. If I want to put vectors, I have to look, and similarly, I get EC is equal to T times EA, okay? Now, if I want to put vectors, I have to pay attention first. T is positive here, of course, this is positive, because it's a ratio of numbers, so it is positive. Now, if I want to put vectors, I have to see first, do the vectors ED and EB have the same sense? Look here, ED and EB have opposite senses. So if I put vectors, I have to add here a minus. Similarly, EC and EA, I can put vectors, but they have opposite senses, so I have to put a minus because T is. So I had here ED equal minus TEB and EC equal minus TEA. Instead of having this minus T, because I don't want to, I want to simplify things, I will call it K, and this minus T here, I can call it also K. Okay, so this means ED equals KEB and EC equals KEA. Of course, if you understand it directly, you don't need to go through these steps that I explained, if you can see it directly. But for those who find it hard, you can do these steps. Okay, and notice, of course, that K is a negative constant because T is the ratio which is positive. K would be minus T, which is negative. Or you can see that K is negative because ED and EB have opposite senses, EC and EA have opposite senses. Now, how can these help us find the coordinates of D and A in this system? So I have ED equals KEB. Remember, the system is EB, EC. And I want to write ED as a linear combination of I and J, which are EB and EC. Notice here, what do we have? We have ED equals KEB. This means ED equals KEB plus 0 EC. Okay? So KEB plus 0 EC. So this means that the coordinates of vector ED are K0. Okay? So the coordinates of point D are E0 because A is the origin, 0, 0. Similarly, we have EC equal KEA. Okay, but we already have the coordinates of C. I want to find the coordinates of A. So I want to find EA. Divide by K. So we get EA equals to 1 over KEC. Okay? I want to write EA as a linear combination of EB and EC. There is no EB, so it's 0 AB plus 1 over KEC. This means that the coordinates of EA, which are the same as the coordinates of A, are 0, 1 over K. So now we have everything that we want. We have the coordinates of E, B, and C, as well as A and D. Okay, so let's continue. So I copied again here the coordinates in the first line. Now we can find all what we want. So we want to find, we still have to find the coordinates of M and N. M is the midpoint of AB, so to find its coordinates, we apply the rule, xa plus xb over 2, ya plus yb over 2 in the system. So we get 0 plus 1 over 2, 1 over k plus 0 over 2. So this gives 1 over 2 1 over 2k. So this is the coordinate, these are the coordinates of M. Similarly, M is the midpoint of CD. So we do xc plus xd over 2, yc plus yd over 2, we substitute, and we get the following. So now we have the coordinates of M and the coordinates of N. So we have E, M, and N, so we can find vector EM, vector En, and apply xy prime minus yx prime, and show that it's equal to 0 to conclude that the vectors are collinear and hence the points are collinear. Now, to find the vector EM, of course, E is the origin, so EM and M have the same components or coordinates, so EM is the same as M, so it's half 1 over 2k, and En similarly is the same as N, so it's k over 2, 1. We have the two vectors, we apply xy prime minus yx prime equals 0, so this times this minus this times this, and we prove that the result is equal to 0. I did it here. Sorry, I did it here. Okay, so I did it here. So we got 1 over 2 times 1 over 2, which is 1 over 4, minus 1 over 2k times k over 2. K and k would cancel out, and this would give 1 over 4 minus 1 over 4, which is 0. So we conclude that EM and EN are collinear vectors, and since they share a common point, which is E, thus the points EM and N are collinear.